Let's solve one previous question of recurrence relation. This question was asked in GATE CS 2024 set 1 question number 32. Consider the following recurrence relation. T of n equals to root n t of root n plus n for n greater than equals to 1, else it is 1 for n equals to 1. Which one of the following option is correct? And 4 options are given. I already discussed same recurrence relation during lecture. There I considered initial condition as t of 2 equals to 1, whereas in this question it's given as t of 1 equals to 1. Still answer will be same as we are finding approximate, okay, not exact running time. Here I will use backward substitution. So t of n equals to root n t of root n plus n. Root n, that we can write as n power 1 by 2. So t of n equals to n power 1 by 2 t n power 1 by 2 plus n. And in place of this t of root n, so t of root n, that we can write as t of n power 1 by 2 equals to n power 1 divided 2 square, or we can write root of n, then t of root of n plus root n. So t of root n equals to root of n, t root of n plus root n. So this root of n, that we can write as n power 1 divided 2 square, and this root of n here n power 1 divided 2 square, root n as n power 1 divided 2. So in place of this t of root n, we can substitute this value, and after substitution we will get n power 1 by 2, it's given before, and in place of this t of root n we substituted this, then plus n. Now after solve, so n power 1 by 2 multiplication n power 1 divided 2 square. So it will be n power 1 divided 2 plus 1 divided 4, right? So it will be n power 4 here, 2 plus 1, it will be n power 3 divided 4. Then t of n power 1 divided 2 square, then multiply n power 1 divided 2, n power 1 divided 2, it will be n, and before 1 n is given, so n plus n, it's 2n. So we found n power 3 by 4, t of n power 1 divided 2 square plus 2n. So now again simplify this. In place of 3 by 4, we can write 1 minus 1 divided 2 square. So now if in place of this we'll substitute, so after continuing we'll get a general pattern. So general pattern is n power 1 minus 1 divided 2 power I, t of n power 1 divided 2 power I plus I multiplication n. So what we did, in place of this we substituted, again we substituted like this, we are getting a general pattern, and this is our general pattern. Now this general pattern will compare with the initial condition. What is the initial condition? T of 1 equals to 1. So this t of n equals to 1 for n equals to 1, this is our initial condition. During lecture I discussed initial condition as t of 2 equals to 1. If you are considering t of 2 equals to 1, you will get more accurate, but here it's given t of 1 equals to 1. So what we will do, this n power 1 divided 2 power I equals to 1. Now log of 1 base n will be 1 divided 2 power I. So log 1 base n equals to 1 divided 2 power I. And we can switch these two. When we are switching, it will be 1 divided log of n base 1 equals to 1 divided 2 power I. So log n equals to 2 power I. Now 2 power I equals to log n. So I will be log of log n. So here base is 2, here base is 1. So that's why I told initially, if initial condition will be t of 2 equals to 1, if this n power 1 divided 2 power I will be 2, then both base can be 2. Okay. So anyway, we are getting I equals to log of n. This base is 2, this base is 1. Okay. So now substitute the value. We'll substitute here n divide n power 1 by 2 power I. So this whole is 1. This whole is 1. So n divide 1, then t of 1, then in place of this I will write log of n, then there one n is given, so we'll write n. N divide 1, it's n, t of 1 is 1. We got n plus n log of n, right? Before one n is given and I value found as log of n. So n multiplied by I equals to n multiplied by log of n. So now n plus n log of n, from these two, higher value is this one, n log of n. That's why running time will be order of n log of n, or you can say theta of n log of n. It's present in option A. That's why answer will be option A, theta of n multiplied by log of n. I already discussed similar type of examples during lecture. Just go through the lecture, and if this lecture is helpful for you, please like, share and subscribe. Thank you.